move you on and wrap things up for today. So here's A and here's B again. This is a sine wave. B is the frequency, which is 3. A is the amplitude, which is a half. The period is 2 pi over B. You got all this memorized already? 2 pi over 3 you cannot reduce. The reason I wanted to do this is this one you should probably then rescale everything. So you're not going to use our normal going by a quarter pi. If it's 2/3 of pi, I probably want to number this by thirds. 1/3, 2/3. Here's my pi now. 1, 2, 3. Here is 2 pi. So every tick mark would be a third pi. This would be 2/3 pi. 1 whole pi. 1 1/3. 1 2/3. And then you'll see the sine graph. And it has an amplitude of only a half. So sine starts at 0, 0. I would go out to the end of the period, and that's where I'm going to stop my wave. So remember, when you change the frequency, you're not going to go all the way out to 2 pi. Now remember, sine has 3 x-intercepts. So it starts at 0, ends at 0, 0 in the middle. And then it goes up before it goes down, and it's not going up very high in this one. It's only going up a half and down a half. So there's your sine wave. A little review for you. I like to use this vocabulary or this terminology. Sine starts at 0, ends at 0, 0 in the middle. And again, those numbers relate to me because I've been called a 0, most of my life. Just kidding. Cosine starts at 0 amplitude, if that makes sense. So a normal one would start at 0, 1. And it ends at 0, whatever the amplitude is. And in the middle, it is down low. It does not cross the x-axis. So those are some things you'll hear me say when we do some shifting around in our next video. All right, for the easy part of today, let's take some information about a graph or look at a graph and see if we can write the equation. Remember, here's your parent function, y equals a sine bx, where a and b are 1. We're going to change it. So now if a is 2, well, that's a piece of cake. I just plug that in there. And now this one you can do with some common sense, and if you struggle with it, you can do it mathematically as well. So now if the period is 4 pi, that means things got stretched out. The formula for period is 2 pi over b. Well, that has to equal 4 pi in this case. If you just think about b as being 1, 2, 3, 4, it doesn't work. If b is 1, I get 2 pi. If b is 2, I get 2 pi divided by 2 is 1 pi. If I do b is 3, I get 2 pi over 3. I'm going in the wrong direction. So if I try fractions, and if b is a half, 2 divided by half is 4. So you can see my answer is going to be 2 sine 1 half. The other way, if you don't like that, if you can't picture it, you can make this an equation to solve for b. What would you do? Multiply both sides by b. You now have 2 pi equals 4 pi b. Remember what you're solving for. You're trying to find b. So this was my equation. Period is 2 pi over b. In this case, it's equal to 4 pi. I multiply both sides by b. Those cancel. And now, to solve for b, I divide both sides by 4 pi. Well, what is 2 pi divided by 4 pi? Pi's cancel, 2/4, 1 half. So that's what I said. You can do it with your common sense, or you can do it mathematically. Here are a couple for you to try. What I would recommend is you pause the video and see if you can fill these in. I'm going to start filling in the amplitude. So for number 12, we know it's 3/4 cosine. For number 13, we know it is 1/5 cosine. I'm just plugging in the amplitudes. It's a piece of cake. And we know for number 14, it's y equals 5 sine. The only thing that takes a little bit of thought is finding the period. You need to remember the formula for period is 2 pi over b. So for this one, 2 pi over what gives you pi over 2? So I'm going to do my guess and check way. If I try 1, that's obviously not it. If I try 2, I get 2 pi divided by 2 is pi. I'm going in the right direction. If I try 3, it's not going to work. But you know what? If I try 4, 2 pi divided by 4 is pi over 2. And It's when these numbers are smaller, it's kind of easier. When you get a bigger number here, you should guess that it's going to be a fraction. This one I'm going to do mathematically. 2 pi over b equals 8 pi. Multiply both sides by b, and I've got 2 pi equals 8 pi b. Remember what you're solving for. You're solving for b. Divide both sides by 8 pi. 2 pi divided by 8 pi, the pi's cancel. 2/8 is 1/4. And my last one here, pi over 3, I'm going to use my formula. 2 pi over b. If I try b as 1, 2, 3. If I try b as 3, I get 2/3. If I try 4, I get 2/4. 5, I get 2/5. 6, I get 2/6. What's 2 pi over 6? It's 1/3 pi, or pi over 3. Those are your answers, and I hope you maybe pause the video to find those ahead of me. Here's the fun part. Now you got a picture, and can you come up with the equation? So remember what the parent graphs look like. Sine starts at 0, 0. Cosine starts at 0 amplitude. There's your parent function. If you look at this one, it starts here at 0, 2. That's a cosine. Because we know that sine starts at 0, 0. The amplitude is pretty easy to see, I think. It's 2 above, it's 2 below. The period gives people a little bit of trouble, so I say trace it on your graph. It starts here, and it ends here. That is one period. Starts high, ends high, in the middle it's down low. And I've got my 2x intercepts. So the period is how far it went. It went pi, everybody. Then I need to know my formula for period. We just practiced this. 2 pi over b. Well, what must b be so that 2 pi equals pi? Well, to me, it's pretty obvious. It's got to be 2, so they cancel. So my answer is y equals a, whoops, this one is cosine, bx. A was 2, b was 2. Tracing one wave on there, I think, is very helpful. Here is another one for you to try. Again, I would pause the video so you don't see the answer. See what you can come up with. It starts at 0, 0. I'm going to trace one wave. Here's where it would end. Its period is pi again. Remember, the period is how far it goes before it starts over again. The amplitude is pretty easy to see. It's got to go the same height above and below the x-axis. This one is 4. This is definitely a sine since it started at 0, 0. Remember, sine starts at 0, 0. So I know it is y equals a sine bx. So I know it's 4 sine. And again, it's the same as the other one. The period is pi. And if you like the mathematical way, in for period, you substitute the formula, 2 pi over b equals pi, and you solve for b. So I multiply both sides by b. These would cancel, and I've got 2 pi equals pi b. Divide by pi, and you can see that b is 2, just like it was on the previous slide. And I think, oh, we have one more. This will be our last one, everyone. Again, pause the video and see if you can do it. This is the hardest one, of course. See if you can figure out which one it is. And I'll go through the steps. All right, it starts up here at 0, a half. So it's not sine, it's cosine. Sine starts at 0, 0. The amplitude is pretty easy, it's a half. Now the period in this one is going to be your challenge, because cosine starts at the period and ends at the period, but you don't get to see it. You don't know where that is, so this is where its symmetric properties come into play. At 2 pi, it was down low. You need to remember then that at 2 pi, that is halfway. So when we get to 3 pi, it would cross the x-axis again, and 4 pi is where it would be back up high. So the period of this one, everybody, is 4 pi. So what you just saw, when we get to here, that's only half of the period. You need to get the other half. So now to find b, 2 pi divided by b has to equal 4 pi. The higher this number makes this a fraction. B is a half. I'm just going to use the guess and check. If you want to multiply both sides by b and solve for b, you sure can. So my answer for our last problem is 1/2 cosine 1/2 x. Happy graphing with sine and cosine. Thanks for listening. Practice those parent functions and you'll have this down. It's fun and kind of easy, but it takes a little practice. Good luck, everybody.